All right, today we're going to demystify something absolutely fundamental to Linux scripting. A little thing that can save you a world of headaches, the shebang. But let's kick things off with a question I know you've run into if you've ever managed more than one server. Why is it that a script can run flawlessly on your machine, but then you move it somewhere else and suddenly it just breaks? Check this out. On server A, our script runs no problem at all. On server B, the exact same file fails with a weird syntax error. What is going on? This is one of those classic hair-pulling mysteries in the world of DevOps and sysadmin work. So, how are we going to solve this thing? Well, here's the plan. We'll start with our tale of two scripts. Then I'll introduce you to the hero of our story, the shebang. We'll talk about why interpreters matter, stock up your scripting toolkit with the essentials, put it all together in a real-world example, and then wrap up with the key takeaways. Sound good? Let's go. All right, so let's get right back to that mystery. We've got two identical scripts, but completely different results. I mean, how is that even possible? Well, the answer, like so many things in Linux, is actually kind of elegant, and it's been hiding in plain sight this whole time. It all comes down to what you put, or more importantly, what you forget to put on that very first line. And that brings us to the main event, the concept that's going to unlock all this for you, the shebang. Yep, it's just these two little characters. You've got a hash symbol or a pound sign right next to an exclamation point or a bang. You put them together, hash bang. Shebang. See where the name comes from? Okay, so what does this thing actually do? Well, you can think of the shebang as a special instruction, a little note you leave for the operating system itself. It's basically you saying, hey, OS, don't just guess how to run this file. Use the exact program I'm telling you about right after these symbols. And this right here is the one you're going to see everywhere. /bin bash. This one line is crystal clear. It tells the system, listen up, this is a bash script. I need you to run it using the bash interpreter you'll find at /bin/bash. No ambiguity. So what happens under the hood? It's actually super simple. You type /script-sh, you hit enter, the operating system kernel opens up that file, and it only reads that very first line. It sees the shebang, and it goes, aha, I need to start up /bin/bash. Then it just hands the rest of the script over to that new bash process and says, here, you deal with this. It's a clean, simple, and really powerful handoff. Okay, so we know what it is, but that doesn't quite solve our original mystery, right? Let's connect the dots. Why is specifying this interpreter so important? Here's the kicker. The default shell isn't the same everywhere. On a system like CentOS, for example, the generic /bin/sh is usually just a shortcut, a link, to the full-featured bash shell you know and love. But on a modern Ubuntu system, that same /bin/sh points to something called dash, which is way more lightweight, faster, but it's missing a bunch of features. And that right there, that's the root of our problem. And this is really the whole point. If you write a script that uses a fancy feature that only exists in bash, but then it tries to run using dash, boom, it's going to crash and burn. By putting /bin/bash at the top of your file, you're demanding consistency. You're ensuring your script runs in the exact environment you wrote it for. This is absolutely crucial for things like cron jobs or system services, which can have totally different default settings than your own interactive terminal. All right, so now we get it. We know how to make our scripts dependable with the shebang. So let's talk about what we actually put in them. It's time to build out your essential scripting toolkit with the core building blocks you'll need to write some really smart and powerful scripts. So here are the heavy hitters we're going to cover. We'll look at how to make decisions with if, we'll see how to loop with for and while, we'll talk about getting user input with read, making number lists with seek, and then controlling our command flow with the super useful and or operators. We'll even quickly touch on the exec command. First up, making decisions. The if statement, along with the test command, which you usually see as these square brackets, is how your script thinks. You can check for all kinds of things. Like in this first example, the -f flag is testing if a file exists. In the second one, -gt is checking if one number is greater than another. Super powerful stuff that lets your script run certain code only when a condition is met. Okay, what about doing things over and over again? For that, we've got loops. A for loop is your best friend when you have a list of things you need to work through, like a list of servers, files, or usernames. A while loop is a bit different. It just keeps on going as long as some condition is true. This is perfect for stuff like waiting for a process to finish, or in this example, just counting up to a certain number.
Now, if you want your scripts to talk back, the read command is what you need. It just pauses everything, waits for the user to type something and hit enter, and then it saves that input into a variable you can use later. And for those times you need to loop a specific number of times, the seek command is a super clean way to just generate a list of numbers, which you can then pop right into a for loop.
Now, this is one of my favorite things about shell scripting, command chaining. It's all based on a simple idea. When a command works, it exits with a status of 0. If it fails, it exits with a non-zero status. So the double ampersand, and, is a logical and. It will only run the second command if the first one succeeded. A perfect example, mkgr new directory, and cd new directory. Make the directory, and then, if that worked, change into it. The double pipe a pipe, is a logical or. It runs the second command only if the first one failed, like try to ping Google, or if that doesn't work, tell me the host is down. So useful. All right, enough theory. Let's see how all these pieces fit together to build a script you might actually use. So here's what we're going to do. We're going to write a script that, number 1, starts with the correct bash shebang. Then it's going to loop through every single item in the current directory, and for each item, it'll use an if statement to figure out if it's a file or a directory, and then tell us. And here's the script. Check it out. Right at the top, line 1, we have our /bin/bash shebang, making sure it runs the same way everywhere. Then, for item in all, kicks off a loop for every single thing in the folder. Inside that loop, we have our if statement. Square bracket, -d, square bracket, item, asks, is this item a directory? If it is, we print that out. If not, the elif, that's else if, jumps in and asks, okay, well, is it a file, using the F flag. And just like that, we've combined the shebang, a for loop, and if statements into a simple, practical tool. Phew, we have covered a ton of ground, haven't we? We went from a really frustrating mystery all the way to understanding the core fundamentals. So let's just quickly wrap up the most important points you need to remember. Look, if you only take away 3 things from this, make it these. First, the shebang. That's your script's promise to the operating system. It guarantees the right interpreter gets used every time. Second, shell constructs, things like if and for. Those are the brains of your script. They provide the logic. And third, operators. Remember and or? They give you that fine-tuned control over how your commands actually run. So now, with these tools in your belt, you are absolutely ready to start writing more dependable, more portable, and way more powerful shell scripts. The only question left is, what's the first tedious thing you're going to automate?